Autobots, roll out!
This is my baby, and I'm the one that made it walk and talk. So I made it walk by calibrating the forward and turning movements, as well as the sensors like infrared and ultrasonic. I made it talk through communication protocols to communicate with the alpine. The biggest challenge I faced was the calibration of movements. Movements in and out of the lab had different sets of values, and I had to carefully calibrate them for precise movements. The gaps on the tiles outside affected the turning, so the position where the robot turns will have different turning radius. I solved this through weeks of calibration.
I'm in charge of the Raspberry Pi, which is this thing here. So it facilitates the communication between the various devices by sending and receiving messages. So how I did it was I used a multi-threaded program. So using 2 threads for the connection between the different PCs and the RPi over a network socket. Then the 3rd thread is used for like Bluetooth connection between the Android tablet and the RPi. And the final thread is used for a connection over UART with the STM32. Yeah, so I use a multi-threaded program so that the different threads can run independently and concurrently at the same time.
Hi, I'm in charge of image recognition, which makes use of a custom YOLO V5 model trained to recognize symbols with a dataset of 3,500 images augmented to account for lighting and motion blur. An image processing server is used to receive images from the RPi and to process the images using the trained model. The inference results are then processed, comparing vertical bounding box height to find the symbol closest to the camera, and then outputting an image with the bounding box of the detected result.
We are the algorithm team. For our robot, we implement the nearest neighbor algorithm to decide the shortest path based on the distance between the current point to the next obstacle.
After finding the shorter path, we further optimize the algorithm by using our path decision algorithm to simulate the movements of the robot by considering the placement and the phase of the obstacles.
This algorithm will produce a set of movements from point to point. After generating the movements, it will be simulated on our laptop and also be sent to the RPi to be processed and sent to the STM.
Hi guys, we're in charge of the Android, and here we have the UI, and it's capable of connecting to the RPi as well as the robot to send obstacle coordinates as well as update robot position over here on the Android UI. Okay, so over here we have a simple yet unique UI for the Android, and on the right here we have the obstacles to be placed. At the bottom we have buttons for configuration such as connecting to the RPi and the robot via Bluetooth, as well as setting obstacle phase, setting robot start position, and sending obstacle coordinates. So first we place the obstacles. As you can see, they resize upon touching so as to allow the user to know where he's placing the obstacle. Okay, once we set the obstacles, we then set the robot start position. Then we send the obstacle coordinates. And now when we press the start button, the robot position will be updated on the UI by receiving string messages from the algorithm. As you can see, the robot position has been updated, and now we'll go ahead and identify the obstacles. Once the image recognition recognizes the image on obstacle, it will update the image ID on the obstacle by sending string messages. And the text on the obstacle will be resized to be larger and display the correct image ID.
We face many challenges along the way. For the robot, the calibration of the forward and turning movements. Next, the system does not react to sensors quick enough for fast movements, and the different battery level changes the movement of the robot. And the UART transmission sometimes also fail to receive the message. For the algorithm, the allowed number of movements for each path calculation has no ideal value as each map has different difficulty. The path decision algorithm was designed to simulate the robot movements. However, this caused it to be unable to solve some simple maps due to the limit set. For the image recognition, its accuracy is affected by difference in environment, leading to a requirement of a more variant dataset, inclusive of different lighting conditions and viewing angles.
Autobots, roll out!